Hey kids, so this is our friction lab, and when you come to this home screen, it might look like this, but I want you to click over here on this friction area and then click it again, and it should open up a screen that looks just like this. Now, today's lab is all about friction and applied force related to friction. I'm going to talk to you about it for a minute to kind of give you a little bit of a brief lesson on this before we start, and then just go through the lab and enjoy it. Please remember that when you do the lab, you make a choice to do the lab yourself or to do it with me, and the section that you do not choose shows up as ungraded. Okay, so when you review your answers, only look at the sections that you chose to do. Okay, here we go. So when you get in here, it looks just like this. And this is all we're going to focus on right now is this box and the robot pushing the box. You'll remember last week we had I believe a skateboard or a cart. Now when we set up, we're going to do sum of forces and mass. Okay, so it gives us the mass of the box, 50 kilograms, and the sum of forces. And that's basically going to show us when the force is balanced and unbalanced. Now down here, this is our applied force, just like we did in the other lab. And each time you click one of these, I'll click it once, it gives you force in newtons. The greater the number here, the greater the amount of force applied. So the pushing force going this way to the right is the applied force. And actually what's happening right now is the friction on the ground is pushing back. That's a little hint to the first question, okay? Now you'll notice up here the sum of forces always shows as 0 until it moves. So I'll do it really quick. Boop, 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 boop. See, now all of a sudden the applied force is greater. See the applied force arrow is greater than the friction force. So that means the force is not balanced, which results in motion. Remember we learned that in 3rd grade with the tug of war? Unbalanced forces result in motion. Okay, let me reset. Now for your lab, you're going to be testing the impact of friction on the amount of force needed to move an object. And that brings us to this little slider here. So you're going to do one test with it way over here with lots of friction, and then you're going to do another test, and watch what happens to the ground. It turns to ice. Ice is slippery, right? With no friction. So you're going to run 2 tests with this box with lots of friction and with no friction. Now just think for a minute and make a prediction in your head. Is it going to be easier to move the box with no friction on ice or lots of friction? Lots and lots of friction. So think about like trying to slide across a frozen pond or trying to slide across pavement. Big difference right there, that friction. Okay? That's the gist of this lab. Okay, so that's all you have to do is go through the experiments, answer the questions. If you have any difficulty, let me know. Send me a note. And remember, at the end, when you review, some of your questions will not be answered because you make the choice to either do the lab with me or do it on your own. Either way is perfectly fine. All right, get to work. Bye.